Welcome back, Math 2. Today we're going to discuss how to use the powers of I wheel. So there's kind of this pattern that the complex number I, which, quick reminder, hopefully we discussed this today, that I is equal to the square root of -1. It is the imaginary number often referred to. The reason we even have this is so that we can solve problems that typically don't have a solution, because you can't take a square root of negative numbers unless you use I. Okay? So I has kind of this pattern. So I to the first, which is on the left of this wheel here, is equal to square root of -1. But if we then were to square it, okay, remember, an exponent of 2, so if I square the I have to square the square root, and a square root cancel each other out. So I squared actually becomes a real number, -1. And that's another reason we use it, because if you end up with more than one I, there's a chance that your answer could become a real number. Okay? If I cube it again, if I kind of square it again, or if I have 3 of them, so square root -1, square root -1, square root -1, multiplying all of them together, the first two simplify to -1, just like I squared did, but we still have a leftover -1. So this becomes this becomes negative I, because it's -1 square root -1, and this is just I. Okay. So we start off with, I didn't actually want to make that square root of -1 there. This one right here, why is it not erasing? There we go. This one, I'm sorry, I to the first power is just I. And then it circles back around, I to the 0. If I were to throw in another I, like I to the 4th or I to the 0, remember, anything to the 0 power, including I, simplifies to a +1. Okay. And I'm going to come back up to this wheel here, but let's fill in some of these blanks here. So this wheel, or this pattern, starts over every 4 spaces. Okay. So when you're dealing with larger exponents of I, you can either count, like literally count around the circle, or you can divide the exponent on I by 4. Okay. Now here's what's going to happen. When you divide it by 4, you will either get a whole number or it will end in one of the following decimals. It'll end in 0.25, 0.5, or 0.75, because this happens in increments of 4. So it's like a quarter, half, and 3/4. If it ends in a 0, meaning there's no decimal, or I'm sorry, it doesn't end in a 0. If there is no decimal, it comes out to be a whole number. That puts you up here, okay? Meaning that whatever that exponent is equal to would take you all the way back to equaling 1. If you land on 0.25, that would put you here, equaling I. 0.5 gets you down here to -1. And 0.75 brings you around here, so it's a full circle. Okay. Here's what I mean by that. Let's jump down to our examples, and I'm just going to do a quick little circle. So my options are 1, I, -I, no, that's not it. I'm sorry, 1I, -1, -I. They're kind of opposites of each other. And I've got 0, 0.25, 0.5, 0.75. I'm just putting it down here so I don't have to scroll back up and forth. You don't have to redraw them. Okay. My first example is I to the 8th power. Okay. So I could either start and say, okay, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and get all the way back up there. Or I can just do 8 divided by 4, which comes out to a nice whole number with no decimal or like a 0.0. So that tells me that I to the 8th is equal to 1 because there is no remainder. But I to the 9th, if I do 9 divided by 4, I am left with 2.25. And that 0.25 tells me I'm going to go one further step and get back to I. Okay. If I go another one, 10 divided by 4, I end in a 0.5 number. So that tells me that this is equal to -1. 11 would get me to that 0.75, so this is -I. Now, none of those would have been terrible to like count around the circle, but still not easy to do or annoying. It's kind of annoying. If I move on, if I do 55 divided by 4, with bigger numbers, I get 13.75. So that 0.75 tells me I want a -I. Now these last two have numbers in front of I as well. And here's why it was important to use I, because sometimes it can turn into a real number. I'm still going to do my 15 divided by 4, which it has a number that ends in a 0.75. So it's going to be -I. But with this 3 out front, it really means that it's -3I. So that changes my answer a bit. Instead of what looks like a positive number, I know it's actually negative now. So that changes things. And my last one, I'm going to do 18 divided by 4, which ends in a number that has a 0.5. So that means my I is now actually a -1. But again, with this 6 here, it's actually -6. And that changes things big time. Instead of having an imaginary number now, I have an actual answer that I can use towards further things. And that is how we use that power of I wheel.